Hello. One of the less glamorous skills that you'll have to master in this course is converting units. You'll be doing this in problem solving, and you'll be doing it in laboratory investigations. And so this tutorial introduces you to some basic techniques for converting units. Many units exist for any given quantity. In fact, if you think of the example of length, there are many different units that can be used to measure it. We commonly use inches, yards, miles, and meters. In fact, there are dozens, if not hundreds, of different units that can be used. A useful device for converting from one unit to another, especially for non-metric conversions, is called a conversion factor. A conversion factor is a multiplier, and you multiply the given information times the conversion factor to give you the answer. So in this example, we're given a length of 1,250 feet, and we're asked to convert it into miles. That can be done by constructing a conversion factor in which feet are placed in the denominator, miles are placed in the numerator. And in this way, feet will cancel feet, and miles will carry through. You need to look up the actual value for this conversion. So 1 mile equals 5,280 feet. But once you've set up the conversion factor with miles on top and feet on the bottom, you know that you have to divide by 5,280, not multiply. And so this kind of is a fail-safe way of making sure that you're doing the right thing. So the answer that we get is actually quite small, because 0.237 miles is less than 1 mile, so roughly about a quarter of a mile. So this is how you use conversion factors. Be especially careful when converting area and volume. And the reason is that you have to square or cube the conversion factors themselves. So as an example, let's say that I ask you to convert 3 cubic feet into cubic inches. You should expect to have a number of cubic inches, which is pretty big, bigger than 3, because cubic inches are small. However, you might think that it's okay to just multiply 3 times 12 and get an answer of 36 cubic inches, but this would in fact be false. What you have to do is take the conversion factor and cube the entire factor. So I would take 12 inches per foot, and I'd have to cube the entire thing. And after I do that, I find out that there are in fact 1,728 cubic inches in 1 cubic foot. That's the number that I multiply by 3 to get the correct answer of 5,184 cubic inches. You can imagine I'd have to do the exact same thing with an area problem, except I would be squaring the conversion factor. One of the major disadvantages of the system used in the United States is that there is no standard system for changing the scale of the units. If you think about length, we've already seen a few examples. There are 12 inches to a foot, 3 feet to a yard, 5,280 feet to a mile. The numbers 12, 3, and 5,280 are numbers you'd have to look up. The same thing can be said for volume, and there are some examples on the bottom here. And if you've lived in the United States for any length of time, you may know some of these, but oftentimes we have to look them up, and this is kind of inconvenient. So in science and engineering, we use the metric system. And the metric system uses a system of prefixes to change the scale of a quantity. The prefixes modify the base units, and the prefixes are based on multiples of 10, which is what makes the metric system so easy to use. There are a lot of metric prefixes, but I think in this physics class there are 6 that you really should just memorize. The 3 prefixes on the top are prefixes which make the scale smaller. Micro is 1 millionth, milli is 1,000th, and centi is 100th. These are very common prefixes. So for example, a centimeter would correspond to 100th of a meter, or 0.01 meters. The prefixes on the bottom increase the scale. Kilo is 1,000, mega is 1,000,000, and giga is 1,000,000,000. So if you are playing in the mega lottery, you're talking about a lottery for millions of dollars. So a couple of little examples here. Normally we talk about paying for something, and you might say that something costs 50 cents. Well, if you really want to freak out the person at the store, you could say, I'd like to pay 50 centy dollars. Because in fact, a cent is exactly that. It's a centy dollar. It's 1/100th of a dollar. For an example with computers, you might talk about a file that has a size of 1 megabyte. And that would mean that the file has a size of 1 million bytes, or 1 times 10 to the 6 bytes. So I think these are probably examples which are hopefully familiar to you. There are a few others here. If you're traveling outside of the United States, you'll notice that road signs are often indicate distances in kilometers. A kilometer is 1,000 meters. The prefix kilo means 1,000. Sometimes for mass, you'll see kilograms. And of course, a kilogram is equal to 1,000 grams. So those are common quantities, length and mass, which are used in physics. So we're going to wrap up here with a couple of examples. I'd like you to be able to convert metric units fluently, which means quickly and correctly. And you really don't need to use a calculator at all, and that's the whole benefit of the metric system. Sometimes teachers will teach you to write down conversion factors when you're converting metric units, but it's really not necessary at all, and I'll show you how to do that. So the two questions you need to ask are, number one, how many places will the decimal move? And number two, in which direction will it move? And the rule of thumb is if you go from a big to a small unit, the decimal moves right, or you increase the exponent. If you go from a small to a big unit, the decimal moves left, and you decrease the exponent. So I'll show some examples, and what I'll use here is a device called the Stairway to Prefixes. And I like this one because it kind of lays out all the prefixes and how they show up and how to use them. Now you'll notice in the middle of this picture here, this long line right in the middle is where you have the base unit. Now if you increase the scale of your measurements, you're going to be going up and to the left. So from the base unit to get to the kilo prefix, you would take 3 steps up. And every step is like multiplying by a factor of 10. So going up 3 steps is multiplying by 1,000. And then you get to mega, which is 6 steps, and giga, which is 9 steps. On the right side, and the lower side, this is when you take the base unit and you make it smaller, or you make the scale smaller. And so taking 2 steps down brings you to centi. Taking 3 steps down brings you to milli. 6 steps is micro, and 9 steps is nano. So a couple of examples here. Let's say that you want to convert a mass of 5 kilograms into grams. Kilograms to grams. That's a big to a small. Okay? The base unit is gram. The prefix is kilo. So since you're going from big to small, you are going to add 3 to what you started with. So in other words, I would take 5 and I would move the decimal point 3 places to the right, or I would add 3 to the exponent. So my final answer would be 5 times 10 to the 3rd grams. And that should make sense because a kilogram is large compared to a gram, and it should be equivalent to many grams. Another example, let's go from the base unit of seconds into milliseconds. So 0.5 seconds into milliseconds. I would be starting at my base unit, which is right in the middle, and I would be taking 3 steps down to get to milli. Now I'm still going from big to small, so I'm still going to add 3 to the exponent. I'm still going to move the decimal point to the right by 3 places. And so my answer would be 5 times 10 to the 2 milliseconds, or 500 milliseconds. In a third example here, let's go from small to big, 250 micrograms into the base unit of grams. So in this case, starting at micro, I would have to take 6 steps up the ladder. I would be subtracting 6 from the exponent, or moving the decimal point 6 places to the left. And so I would be going, I could write my answer as 250 times 10 to the negative 6th. And if I'd like, I could put that into scientific notation and instead write it as 2.5 times 10 to the negative 4th. So I've gone from small to big. And the last example I'll put up here is what happens if you're going from one prefixed unit into another prefixed. So 0.75 kilometers into centimeters. Well, hopefully you recognize right away this is big to small, and you've got to identify how many steps to move. So starting off at the kilo step, I would go 1, 2, 3 steps down to the base unit, and then I need to go an additional 1, 2 steps down to centi. So I've taken a total of 5 steps. Therefore I'm going to move the decimal point 5 places to the right, or I'm adding 5 to the exponent. And so that my final answer is 7.5 times 10 to the 4th centimeters. So a few examples there for you to think about. Notice I have not used a calculator for any of these, and I do not expect you to use a calculator when you do metric conversions. I'm going to wrap up this tutorial by giving you 5 self-check problems here. What you might want to do at this point is pause the video, write down the answers for the 5, and after you have all 5 written down, you can play the video and check your answers. Okay, so you can pause it now. And now you've got your answers here, and hopefully you did okay on this little self-check exercise. So just to review, what we've done is I first of all showed you how to use conversion factors. Those are useful when you're converting in between non-metric units, or between units which are metric and non-metric. You need to set up a conversion factor to use conversion factors. The preferred method, though, is to use the metric system, and with the metric system, conversion factors are not necessary. You're merely moving the decimal point or changing an exponent by recognizing the value of a set of prefixes. Okay, well, I hope you had fun. Be sure to go and try some more on your own so that you're really good at these, and we'll see you soon. Bye-bye.